Hello everyone. Welcome to this presentation on communication in distributed systems. Here, we will explore message passing and remote procedure calls, which are the fundamental communication mechanisms used in distributed computing environments. Let's dive in. Let's first understand what distributed systems actually are. Distributed systems are collections of independent computers that appear to their users as a single coherent system. The components, which are located on networked computers, communicate and coordinate their actions by passing messages. Distributed systems enable resource sharing and fault tolerance, making them a very reliable choice. Examples of distributed systems include cloud computing, distributed databases, and blockchain technologies. However, distributed systems also come with a unique set of challenges. These include communication between distributed components, coordination and synchronization, handling partial failures, maintaining consistency across distributed data, and ensuring scalability and performance. In distributed systems, there are two primary communication paradigms: message passing and remote procedure calls. Message passing involves direct communication between systems via messages. Remote procedure calls, or RPC, allow a system to execute procedures on another system as if they were local. Both paradigms serve as a way for systems to communicate, but they differ significantly in their implementation and abstraction level. System A and System B communicate through these communication mechanisms, enabling distributed operations. Now let's explore message passing in detail. Message passing is a communication mechanism where processes exchange data by sending and receiving discrete messages, without sharing memory address spaces. Key characteristics of message passing include explicit send and receive operations, no shared memory between processes, and the ability to be either synchronous or asynchronous. Messages contain both data and metadata, providing context for the communication. There are different communication patterns in message passing, including point-to-point, where there is direct communication between two processes, multicast, where one sender communicates with multiple receivers, and broadcast, where one sender communicates with all processes. As you can see in the diagram, process A sends a message to process B. This message is discrete and self-contained, ensuring that each process operates independently. When implementing message passing, it's important to consider whether the communication should be synchronous or asynchronous. In synchronous message passing, the sender blocks until the message is received. In asynchronous message passing, the sender continues execution immediately after sending the message. The system can be buffered, where messages are stored in a queue if the receiver is not ready, or unbuffered, which involves a direct handshake between sender and receiver. The diagram illustrates a message queue between the sender and receiver. Here is an example of basic message passing code. The send message function takes a destination and message, creates a packet with source, destination, data and timestamp, and transmits the packet. On the receiving end, the receive message function waits for a message and then processes it. This code is simple, but it shows the fundamental steps in message passing. Now let's delve into remote procedure calls, or RPC. RPC is a protocol that allows a program to request a service from a program located on another computer without having to understand the network details. Key characteristics of RPC include the abstraction of network communication, making remote calls appear local and synchronous by default, and requiring an interface definition. The components of RPC include a client stub, which marshals parameters, a server stub, which unmarshals parameters, an interface definition language, or IDL, and binding, which involves finding remote services. In the diagram, a client process communicates with a server process. The client sends a request, and the server sends back a response, abstracting away the complexities of network communication. In implementing RPC, the mechanism involves several key steps. Stubs, which are client and server proxies, handle the network details. Marshalling involves converting parameters to a network format, while unmarshalling converts the network format back to parameters. Binding involves finding and connecting to remote services. The diagram shows the interaction between client, client stub, and server. Here is a basic RPC example. The interface definition defines a calculator with add and subtract methods. The client code obtains a remote service and calls the add method, printing the result. This code shows how RPC simplifies distributed computing. Let's compare message passing and RPC. Message passing involves explicit send and receive operations. It offers more flexible communication patterns and can be synchronous or asynchronous. It is a lower-level abstraction, giving more control over communication details. Message passing is better suited for event-driven architectures. Examples of message passing systems include Message Passing Interface, RabbitMQ, and Apache Kafka. RPC provides a procedure call abstraction, hiding network communication details. It is typically synchronous and provides a higher-level abstraction. It is easier to integrate with existing code and is better suited for client-server architectures. Examples of RPC systems include gRPC, XML RPC, and Java Remote Method Invocation. The key difference lies in the level of abstraction and control. Message passing offers more control and flexibility, while RPC offers simplicity and ease of use. Let's explore some modern communication technologies. gRPC is a high-performance RPC framework that uses protocol buffers. Apache Kafka is a distributed event streaming platform. RabbitMQ is a message broker that implements the Advanced Message Queuing Protocol, or AMQP. GraphQL is a query language for APIs with efficient data loading. In summary, communication is fundamental to distributed systems. Message passing provides flexibility and control, while RPC abstracts network details for easier programming. Choosing the right mechanism depends on the specific system requirements, and modern frameworks provide optimized implementations to facilitate communication in distributed environments. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.